Hello guys, welcome to this session of LeetCode 60 plus days LeetCode challenge, where we solve LeetCode questions from easy to difficult to hard. And today we are going to solve the number 21 mesh two sorted list. I first of all previously tried this, so I think sometime back when I started LeetCode, but we're going to do this again. Okay. So what's going to happen is that we are going to try to solve this. This is an easy question, and there are two things. I have seen this similar question before. There is these two sorted list and these are linked list. There is also the one or two sorted arrays. I think if you go to the problem, merge, there is some kind of a merge two sorted arrays. Maybe reverse integer, zigzag, string to integer, palindrome, regular expression, longest common prefix, letter combination. I've seen this before, maybe not here, but I've seen it with arrays. But essentially, the idea will be to traverse this list and this list while comparing these values. And rather than traversing both lists, we're going to traverse one at a time. Basically, imagine that you take this n and put it here, but rather you're not taking the n and putting it here. You're kind of like integrating them to form one list, and then you're comparing them. You see what I'm talking about. I know I'm not explaining it well, but in short, you will imagine joining the two lists, and we're going to traverse them as if we're doing one single list, right? And we're comparing the values. Yeah, so this should not take us so much time. Like I said, the question says you are given the head of two sorted lists, linked list, list 1, list 2, merge the two lists into one sorted list. The list should be made by splicing together the node of the first two lists, right? Return the head of the merged linked list. And we have an example here, as this is the first one, this is the second one, and we have 1, 1, 2, so like that. Okay. Essentially, we are going to define our head. And in this case, right, like I said, I've seen this before. Maybe I've seen this before. So I know the solution, so you're not really going to see so much struggle here. But the idea is to define our head. But the head, in this case, we'll define something called a dummy. And the dummy is used to define our head. And we want to avoid manually computing and want to like do the computation while in the loop. And so the dummy is, I think it's something like a list node dummy, right, equals to new list node, right? And basically it can be anything. You can pass -1 there, so it doesn't have to be a number. You can even pass, you can pass -1, -2, you can pass 0. But essentially what you want to understand is that when returning, right, we are not returning this dummy, we'll just return, right, dummy.next. And why are we returning dummy.next? Oh, by the way, if you don't understand what I'm doing here, this is the definition of the list node, this list node. So they have defined it here, so this is what we're using, right? The list node, this next is pointing to the next node within the linked list. And then the int is the value of that particular node. And then you have the constructors. Yeah, so, and why are we returning dummy.next? Now, this is simple. This dummy, as the variable name, is basically a dummy. It's not to hold the next, the head, but it's a place for us to start, right? It's like a handle. You might think of it like a handle to a cup. It's not a cup itself, it's just a place for you to hold something that gives you a starting point, right? So that you can run your computation within a loop, right? Because if we're not to do this dummy, then we'll have to initialize this list node with the minimum between 1 and 2, which can cause problems if the list have some issues down the road. Again, I have seen this question before, I have gone through it, so I'm just trying my best to explain what I understood. So there's some test, if you initialize it manually, so if you want to do like greater than, if this one is greater than this one, then you initialize this one, you use this constructor to initialize the value, and then you set the next node to this linked list. So basically, there is a particular combination of lists and its values that might prove problematic in one of the test cases. Maybe not the first 3 test cases that we're testing here, but when we go to submit, you might see it there. And I'm not going to be running through all of that now, but I think the solution I'm going to provide is probably the most effective solution. Again, it comes from me seeing it. So dummy.next, so that will be the head. And essentially, so define our head, and then we want to define our next. In this case, it will be, so, okay, we want to grow the list as we find the next value, smallest value, right? And to do that, you have the list node, and the next now will become the first node. So the first node will be computing between this one and this one, and we want to find out which is greater. But we want to also make sure that we find out that it is greater within the current node. In essence, the current node will be like the last node. I think it's the last node, right? So because we are growing the list, as we keep growing this dummy list, the current node will be like the last node. So I think we have to do something like list node last, yeah, last node equals to something like this. Yeah, will be equals to dummy, right? So currently the last node is equal to dummy, yeah, and so because now the last node equals to dummy, and we're not using dummy, right? So we just have the 2 nodes we're going to do. So all we have to do is to traverse both lists, considering possibilities of variable length. Yeah, and basically that's simple. I think it's just while list 1 dot next is not equal to null, or list 2 I think it's list 2 dot next is not equal to null. In essence, we're saying that while if any of the lists is not equal to null, this loop is going to continue, right? And here's where the trickery is going to come in, right? Remember, we have the two lists, right? We want to only traverse them once, but make sure that we traverse each node within the two list. And we have to use some kind of a conditional statement, right? So the first thing we have to make sure is this. We have this list, the value of the current nodes, right? These are the current nodes, list 1, list 2. The values, we have to find the maximum, the least value there, okay? And we want to check them against the dummy. The dummy is next, so against the last node, basically, right? The last node value. So, um, node value between negative 100. So, which is interesting. It's very interesting. So we have two nodes, okay? We have two nodes which we're checking, and now we want to put in the dummy.next. The last is dummy. Okay, I see. So, okay, I see what to do here. So basically we're just comparing both, right? We'll compare, I think, so we'll compare both, compare values of each current node. But there's a trick here, is that when you say what we'll be comparing, we'll not necessarily compare this and this, and then when we're comparing the next time, compare this and this. Essentially, we'll compare this and this, whichever one is the smallest, we'll assign them to the last, right? The last node. That's what we'll assign them. So the last node's next. I think it's last node. So last node is equals to dummy here. And so the last node will be equals to we'll assign it to the last node, right? Yeah, so that's what we'll do. So whichever one is the smallest, we'll assign it to the last node, then move to the next node of that list, which is smallest. But the other list, which is the biggest, we'll leave it the same. So next time we'll compare, say, this one and this one. And then this one will now be assigned to the last node. And then this one will be left the same. We'll move to the next one. Then we'll compare this one and this one, only like that. And then we'll gradually, we'll just be moving. So we're going to check if current node to find the smallest value. So we're going to check if list 1 dot value is less than or equal to list 2 dot value, right? We want to first of all take list, want to assign last dot next. Yeah, so we'll do the dot next here, because remember is the head is dummy, so we're returning dummy, right? And we're returning dummy dot next. So to be dummy.next. But when we're dealing with it, the head is dummy and want to assign the next, and dummy is already filled. And so we start assigning to the next values. So last.next will be equal to, so basically it's dummy.next here, which is the same as last.next, equals to new list node, and then we want to assign the value. Is it the value? Yeah, the value. Yes, the value. Want to assign new list node. So we're using this constructor, and list one is the smallest. So I have list one dot value. Yeah. Okay. I think that works. Then we want to increment list one. So I have list one. Then we want to actually then increment the last node, because there are two things we want to do here. We don't want to just do it here. We want to just increment. Okay. I think the comment here will be assign the smallest value to the last node. Next. Or basically assign the smallest value to be the new last node. And then we want to increment list one. So list one dot, so list one equals to list one dot next. Yeah. And then we are going to do else. Basically same thing, but we're going to do list two. Right? So, but there's also something last next equals to this one is two. Is two. And then there is, because if you look, the last node, we always want to update the last node whenever we iterate, right? We want to always update the last node, because the last node keeps growing. So the length of the list keeps growing, and we want to make sure that whenever we want to update the last node, so last node, I think last node will be equal to last dot next, right? And so when it puts this here, then this becomes the last node. So each time we're basically taking this and setting it dot next to the new node. Yeah. So yeah. Set new last node. Is that the correct word? Is it set? Is it like setting? Are we setting a new last node, or updating the position of the last? Update the position of last node. Anyway, which is last. But anyway, you get the idea, right? You get the idea. And is it is it list.next equal to null, or because I don't understand, because if you do dot next list1 dot next, then this one, if this does not have next here, it's going to end here. No, okay, it's going to end. So list1, this comes here. List1 does not have next, so it's going to end here. So if we have this, it's going to end here and here, and so this is not going to work. I think it's probably list like that, right? While list1 is not equal to null, and list2 is not equal to null, and so we're going on each of the node, and we end here, we end here. Is it? I think it's and here. We'll use and because the idea is we want to increment, we want to do that. I don't know. I don't know. I don't know. If list1 dot value, so if at the point the both are null, okay. Right, so let's rethink this. Oh, this is taking more time than I thought it would. Sorry. This is taking more time than I thought it would. Because, okay, it's going to ask the question, what does this, okay, what does this do? So this says that this will continue to run as long as either list1 or list2 are not equal to null. And each time we increment the list1 and list2 to the next, right? Which means that at one point we'll have both here, right? No, we'll have outside of that. I think it's dot next, because then that goes outside of there. Next. Yeah. So basically, it asks the question: list1 dot next is not null. Yes. It's not null. Yes. It's not null. It's not null. It's not null. You're going to get here and ask, is this null? Yes. Is no. Oh, yes. Is this null? No, because it's going to get to a point where it compares like this. Is this null? Yes. Is this null? No. So it's still going to run, and then you're going to come here and ask, is this null? Yes. So is list1 dot next null? Yes. Is list2 dot next null? Yes. And we're going to be left with lists that are, we are going to be left with these two. It's going to compute this one. .next is not equal to null. Yeah. But if we remove the next, then it's going to ask, is list one itself. So it's going to get to a point where it's going to ask the question, are they null? We're going to get here and ask the question, are they null? And it's going to be no. And so it's still going to run. And then it's going to get to a point where it's null and it's null. Essentially, I think I'll do this, right? Remove that list, right? And then I'm going to do, I'm going to use the and here in such a way that once as one of them ends, right? Once as one of them move to the null section, because here this points out to null. So in variable length cases, once as it moves to null, we're going to now come beneath. I'm going to ask a very important question. Check for left. Check for leftovers. Is it like leftovers? Let us say remaining nodes in any of the lists. So we're going to say if list 1 is equal to null and list 2 is not equal to null, right? We want to do, okay, because we have the last incremented, we want to do, so list 2 is the one that is not equal to null. We want to do this. Because we also incremented list 2, we just want to put the last dot next equal to list 2, right? Because what will be left will be the remainder, and they are already sorted, right? I'm going to do else if list 2 is the one that is equal to null this time, and list 1 is not equal to null, and we're going to do last dot next equals to list 1. Okay, I think that should work. Yeah, in my mind it should work, at least, because up to this point this makes sense. This iterates up till it gets out of bound, where it assigns one of these, right? This will work until assign one of this list to null, and then it's going to break. So this check below can work rather well. Let me try that. I hope, oh shit, this is going to give an error there. Yep, so that works. Yeah. and we're going to attempt to submit. Yeah, so yeah, that works. And again, for the second day, we beat 100% of the time. Again, I told you I saw this before. I think for the last two videos, basically I just looked at stuff that I tried before. Yeah, but this same solution, I think the meshed arrays or something, I have solved it before. Let me see. Let me have a crack at some. I have solved it before locally, or I have done it there and I've forgotten. Mesh list. Oh yeah, I've solved it before. There we go. I think this is it. Yeah, I solved it before. So yeah. Yeah, I did solve it before. Only my solution was way longer. Created domain is, oh yeah, sorry. I did solve it before. I think it's the same thing. L1, L2, get var, tails set L. Yeah, I knew that I solved this thing before. Anyway, so that was easy, and luckily I'm solving the game for the second time, which is good. And I hope this explanation makes sense. So if you like this video and you understand what I've been doing thus far, and you love the realistic approach to all of these things, give this video a thumbs up, share and comment what you think, share your different approaches and your time complexity and your space complexity. You see, for space complexity I'm terrible, so I barely beat a bit less than 10% of the people, but for time complexity that's perfect, like 100%, which is awesome. So that's another one solved. Okay, so like, comment and share, and see you in the next video. Bye.